for the virtual servers, what we have done till now.
Okay.
So basically, you can, I mean, it's easy to understand, and if you understand, you can explain her once you have set up and you practice your own.
Okay.
So, you are able to see my screen, right?
Yeah.
Okay. So this is the F5. I'll log in.
Have you started the recording?
Yeah.
Okay.
So now this setup, first I will explain you how is the setup looks like using the lab document. So this is the lab guide that I'm going to follow pretty much. So I have here in this setup, basically this is the diagram, if you see. So this is the client machine from where I would be accessing the F5, as well as from where I would be testing and trying to access the application through F5. And behind the F5 in this diagram, you see there are 3 servers, but in actually I have 5 servers, so which will be doing the load balancing. Okay, so now I'll log in here. So my server IPs are 10.1.1.11, from 10.1.11 to 15, which have the same application on them, so that we can test the load balancing. And my virtual server that I would be configuring will have an IP of 164.58.189.100. okay, so this will be my virtual server IP. So I will this will be through this I will access the application, and then it should load balance me in to these virtual servers. So now basically in F5 we create a pool of servers. Okay, so I already have it created. I would delete this. Okay, hold on. I would do one thing. I will have some configuration. I will remove this first. Okay, let me make it completely fresh. Alright, so first of all I will create a pool which will be a collection of all the servers which will be load balancing for the application, which is ABC. So I will name it ABC underscore pool. Now then I have to associate some health monitor. So now since I am going to access, the application that I am going to access is over the browser and it's HTTP. So the monitor that I should assign is generally HTTP, because I can assign a different monitor as well, like I can assign TCP as well, but TCP will check that these servers are listening on port 80 and they are the F5 can reach them on port 80, but TCP will not check the HTTP service running on the servers, so that would not be the correct test. So that is why we ideally bind HTTP monitor, which will check also that the ensure that the HTTP service is running on the servers. Now once I have chosen the monitor, then the main step is to add the servers. So I will put the server IP. Okay, let's say the name I have to add. So in the name I will add let's say server underscore A, and then this is the IP of the server underscore A is 10.10.1.11, and then I will choose the port, the HTTP protocol. Port 80 by default gets selected, on which the server is listening for the request coming, and then I have to add the second server. So I will put it IP, give it name server B, then again add it. Then the third server is server C, and the IP is 13. I'll add that IP. Fourth is D. I'll give it an IP of 14 and click on add. Fifth is E, and I will give it an IP of 15 and click on add. So this way I have added 5 application servers for HTTP application ABC. What I missed? Okay. Actually, the node, this IP is already somewhere, so I'll just add it once more. 2, 12, 13, 14, 15. Finish. Now this pool is added. It's showing green. What this means, that the pool is available. That means all of my pool members are reachable from F5, and the monitoring is marking them as up. So that's good symbol. And then these are their addresses, and they are listening on port 80, and we are monitoring port 80 and HTTP service from F5. So now this is the backend configuration we have done. Now we have to configure the virtual server on F5 for this application, where actually the traffic for this application will hit F5. So I just give it a name of ABC_VS. Now the destination IP I have to give. So destination IP would be the one which we mentioned over here. So I will pick up this IP and put it here, and then the protocol will be again HTTP, because it's going to be browsed over the browser. I will remain the other default settings as it is. I will just select here SNet auto map, and the default pool, I will select the pool that I created, and then finish. So now traffic will come from external source to this virtual server, something like this, and then virtual server will send it back to the pool. Now if you notice, on this virtual server we did not bind any monitor, but still it's coming green, because this virtual server resources is that pool which itself is green. So if the pool is not green, that would mean that all the servers are down. Even if one server is up, the pool will be green. So if the pool is not green, if considering that all the servers are down, in that case my virtual server will also not be green. So we have to make sure that.
So how will we know the destination address?
No,
the destination IP address.
This we have to basically find out based on, like, this is the virtual server address actually. So this is something that you have to find out based on your network IP addressing scheme, that okay, these are the IP addresses that we are allowed to configure on the F5. Or you can I mean, if there's an application team who's managing it, they can provide you. So see, these are the IP address that is to be reachable over your network basically. So in an ideal case scenario, if I talk about network setup, then something of this sort would be there. A client sending over the internet, sending a request to your data center, where it would be hitting first your firewall, then there might be some core switch behind that, then there would be F5, and then behind that there would be some layer 2 switch, and behind that there would be these servers, right? Server 1 to 5. So now in this scenario, the IP address that we configured on the F5 for virtual server, that is something, you understand the difference between private IP and public IP, right? So this is the private IP that we have configured over here for the VS, and for this we would be doing the NAT on the firewall to convert it or to map it to public IP, and the user will hit that, then firewall will untranslate it or convert it to private IP and send the request to the F5. So this IP of the virtual server that you configure on F5, this is something basically you have to you can get it from the application team, or if you are managing the IP addressing in your network, you would be able to find out what you can use a different VLAN, what VLAN you want to use over here, and based on that the IP address would be assigned. This is something internal to your network.
Okay.
And this should be reachable also, basically the idea is that. So like in my case, this is reachable from my machine. So what I will do in the browser, if I type this IP address, it should take me to the application servers, and I should see the application. Now before I hit enter, I would just like to show you, if I go to my pool, and if I look at these servers, which are the members, and I look at the statistics, so statistics shows 000. So right now there is no traffic on any one of these servers. However, when I access the application, it will show me which server is getting how much traffic. So I just put that virtual server IP. So what it will do, my browser will hit the F5 on the virtual server, and then the virtual server, see, it landed me to, I got the application page, and by looking at this message, I can understand it landed me to the 11th server. I can also verify this. If I refresh, I should see the traffic on 11th server. See, I see the traffic on 11th server. So that means I was landed to it. Now what I will do, I will try to again access this in a different browser, and as per the load balancing, it should take me to some other server. So now again I'm hitting this. Now see, it landed me to 13, and if I go back to F5, I will see some hits on the 13th the server, which is an IP of 10.10.1.13.
Yeah.
So let it refresh. Okay, I see that. Okay, so I can
could
say,
I try it on my system like that, like give it some destination address? Or
yeah, definitely the same thing you can replicate when you set up your lab. So see, what I'm doing is I'm just following this topology which you will set up. So I'm on this machine. On this machine in the browser, I'm typing the IP address of the virtual server. Okay, then that hits my F5. Now that's one part of the communication. Since it's a proxy, then second part of the communication is it sending traffic to sometime this server, this server, this server. Right? So that is what I'm demonstrating basically. Okay.
yeah.
So now this we can try. Another thing is like just now we have in this scenario we have kept the load balancing. If you see, so we have in the local traffic pools we have kept the load balancing method as round robin, which is the default one. And if we make it some other method, then the results might differ. How the traffic gets forwarded to the backend server. We have a lot of options over here, and we'll understand what option does exactly what. I mean, in which scenario basically to use which option, and then we can see then the results would differ accordingly. So now what I can do is I can try and like in a practical scenario, if out of these 5 servers my 4 servers are down, still the website should open up, right? So what I will do, I will just disable these 4 servers. They will turn from green to black, and then I have only 1 server available. Now whatever request I will make, those requests should go to server 11. So now we'll verify that by accessing this again. I'll just refresh it. Okay, so in this browser, if you see, it went to, okay, this is also 11. I'll just access it in Mozilla. I believe it went to 13, right? So now it should go to 11 only. Okay, so it's still going to 11, and now what I will do, I will disable 11, and let's see what happens. It should not open up the page actually. So that means when I disable 11 also, if you look at the status of the pool would have gone, okay, the pool is still showing green, and the virtual server would also be showing green, but actually the page should not come up. So I will just refresh this. See, now the page is not coming up. So that means at least 1 server should be up for that, for me to access. Now let's say I just enable this time 13.1. So all my requests should now go to server 13. See, it now landed me to there. So that's what is giving me expected results, and that can further be verified by stats, though I should just reset them to 0 to make a better comparison. Okay, yeah. Now my stats would increase in 13, right? And further, I can validate the same using the command line. I can see shows this connection command to see on which server the connection is established. It's showing me this. This is established on the server 13 in the last, you can see. So it's showing me this 100 IP, and .14 is my machine IP. So my machine hitting 100, then 100, sending it to .13 server. So you can see the complete flow. Now what I will do is I will go through the next topic, which is pools, which we just configure, but we will go through the details of it so that we have a better understanding of how the pools are configured and what all features are there and how they work and all those things. Okay, yeah, remember one more thing. Yesterday we checked, we studied that we can put a connection limit. So right now all the servers have no 0 mentioned in the connection limit. That means they can entertain unlimited number of connections. But if I want to limit the number of connections, let's say on this server, then I will go to this connection limit section and I will just say, for example, 1. What that means, now this server can only accept 1 connection at a time. So if there will be more connections, it will not be able to accept and it will turn yellow. Okay, so right now if you see these, right now if you see it already, I think, is yellow because it had 1 connection. Okay, so it's yellow because if you look at the stats, it already has a connection. All right. So once this connection dies, it will become green and then it will accept more of those connections. So let me try and initiate another connection and see how it works. Ideally, if it has one connection, it should not take one more connection because the capacity is already breached. But it took the connection, so that means it's just using the existing connections for my new sessions. Maybe sometimes this browser does the caching, so I'll just try and remove it and see how it goes. Okay, so it's still yellow. It has that two connections it took. Okay, so once the one connection died, now this connection also dies after some time, then it will turn green automatically. I don't have to do anything. Okay, so coming back to our concepts about pools. So we did till yesterday in virtual servers. Today we're going to discuss about the pools. Now, a load balancing pool is a logical set of devices such as web servers that you group together to receive and process traffic. Instead of sending client traffic to the destination IP address specified in the client request, local traffic manager sends the request to any of the servers that are members of that pool. This helps to efficiently distribute the load on your server resources. When you create a pool, you assign pool members to the pool. Like we did assign those 5 servers to the pool. A pool member is a logical object that represents a physical server on the network. You then associate the pool with a virtual server on the big IP system, like we did. Once you have assigned a pool to the virtual server, local traffic manager directs traffic coming into the virtual server to a member of that pool. An individual pool member can belong to one or multiple pools depending on how you want to manage your network traffic. The most important part of the pool configuration is the load balancing method. A load balancing method is an algorithm that local traffic manager uses to select a pool member for processing a request. For example, the default load balancing method is round robin, which means local traffic manager to send each incoming request to the next available member of the pool, thereby distributing requests evenly across the servers in the pool. So what round robin means? Simple. Like if I have 5 servers, request 1 goes to server 1, second request to server 2, third to server 3, fourth to server 4, fifth to server 5, and then sixth to server 1, and so on and so forth. So that way it would be equal load balancing across all the members. Now, okay, so these are the other methods. Like the load balancing methods can be categorized into 2 categories: static load balancing methods and dynamic load balancing methods. Static means, in static we have 2 options: round robin and ratio. In dynamic we have 5 options: least connection, fastest, observed, predictive, and dynamic ratio. So let's start. So we talked about round robin. So it's pretty much like this, like 2 clients coming in, and then first request, second, third, fourth, fifth, sixth, seventh, eighth. That's what we observed in our lab also. And if the same thing if the same thing I try to do with the ratio, then let's say if I have 4 servers and I define the ratio 3:2:1:1. Now what that means, server 1 should get 3 requests, server 2 to get 2 requests, server 1 to get 1, and then 1, and then again the same ratio to repeat. Now, so if you look at here, server 1 has 6, first request came to server 1, second went to 2, third went to 3, fourth went to 4. Now when the 5th request comes, as per the ratio, the highest ratio is for server 1. So it will go to server 1. Sixth request comes, it goes to server 2. So seventh request comes, it again goes to server 1. Now it is 3:2:1:1, and like the more requests come, the same cycle repeats. So this gives you an understanding how the ratio load balancing method basically works. Now here's a quick question. If ratio member load balancing is selected and the ratio for servers A, B, C, and D are 3, 2, 4, 1 respectively, how would the next 100 requests be distributed? Servers C and D are currently unavailable. The important point to notice is these are unavailable. So if the server is down or unavailable, then F5 will not consider that server for doing any load balancing and sending any request, because the health monitoring will mark this member as down in the pool. So now considering this scenario, what should be the answer? Because I know only A and B are going to get the request, so first answer is invalid. Now out of B and C, last two options, we have to choose one option, right? And considering that the ratio between A and B is 3:2, so I would say that option B looks better, right? So this would be this is how you can calculate based on the ratio scenario. Now discussing about some of the dynamic options, like the dynamic option first was least connection. Now least connection says okay, before I move on there, I just missed to tell you. So round robin generally we use in a scenario where we have the servers with equal hardware capacity. They have the same amount of RAM and hard disk, so the performance is same, and then that's why we are sending equal amount of traffic. Now ratio we generally use in a scenario where we think that the servers may have different capacity. So like this first server, which I've given a ratio of 3, may have 3 times the RAM, or may have 12 GB of RAM. Server 2 may have 8 GB of RAM. Server 3 and 4 may just have 4 GB of RAM. So that's why I have divided in that ratio, because server A has higher processing capacity and the response time would still be the same. If it processes 3 packets and D or C processes just 1 packet each. So that's how something it's related. Now again, the more we go into the dynamic methods, the same logic would apply. Like least connection. Least connection basically we would use in a scenario where we would like to get the best server performance. Like if at a time one of the server in the pool has high number of connections, which might cause which might affect the performance of that server. So it doesn't make sense to one having high number of connections, we keep on sending it equal requests as we are sending to one which is having low number of connection. So what this method would do is that if a server has high connections and the other one has low connections, the one with the least connection or the low connections will get the maximum request until it equalizes the one with the higher count. So in this case, like you see, server 1 has 459 connections, server 2 has 460 connections, server C has 461, and server D has 470. So server A has the least amount of connections. So now the next request would be coming to this one. Okay. So again, this is a dynamic, because in this case, as the connection count on these servers keep on increasing, decreasing, or changing with the passage of time, the new incoming connection would accordingly be distributed to that server. Then other dynamic method we're going to talk about is fastest. Now fastest load balancing method means in this case the F5 will continuously keep on monitoring the response time of each one of the server. So when I say it is monitoring the response time, it's going to you will assign some monitor on F5 which can capture the performance of the server, and similarly we will have to put some software on these servers which can gather the performance of the server and send it to F5. So like for instance, my server 1 is responding in 10 milliseconds, server 2 is responding in 8 milliseconds, server 3 is responding in 6 milliseconds, and server 4 is responding in 15 milliseconds. So since server 3 is responding in the minimum time, it is going to get the maximum number of requests. Okay, these are the most common methods, like the 4 which we have discussed. Apart from that, we have some other options which are not that commonly used, like observed. So observed basically is a combination of least number of connections plus fastest response time. So out of these 4 servers, the servers which have better average of the two, like least connections plus faster response time, that will get the highest amount of traffic, and that will keep on going like that. Predictive basically is again just observed, but in observe, as soon as F5 will find that this performance is better, it will keep on shifting the load. In predictive, F5 will monitor for the change of performance for some amount of time, after which it will make a decision and maybe change the load between the servers and stuff like that.
So in this dynamic method, so all the servers will have the same kind of performance, like the same capacity?
Yeah, that's pretty much there, but still the capacity may change. Like, see, the reason of keeping fastest method is that for instance, they all may have the same hardware capacity, but what might happen is, let's say the first server at some point of time is not that fast, it's behaving sluggish, maybe some server performance issue or some high CPU, something like that. So I don't want my load balancing or the clients to suffer because of that. So if my F5 will notice that now suddenly this server is responding in a higher time, then it will send less requests to it compared to the other ones. So because see, it's not only that a hardware configuration is the decision maker, like for the server performance. Sometimes there are some dynamic things also happen. Even if the servers have equal configuration, still sometime they may perform differently. So that is why in such scenario, dynamic method is better to adapt accordingly, right?
Okay.
Yeah. So select the dynamic load balancing modes from the list below. So we have these, so it's like a quick questions. Now match across the load balancing with most appropriate description of load balancing across pools. So round robin. Now it matches with the last one, evenly distributed across all. Ratio. So ratio means a percentage distribution across, right? Ratio will divide in percentage. Least connection, lowest open connection count. Fastest means yeah. So fastest means lowest least number of layer 7 requests. Then observed means dynamic ratio set based on open connection count. Now this is the description of okay, another method is dynamic ratio. Like we saw the static ratio in that, let's say if you have 2 servers, you define a ratio of 3:2. It will always follow that 3:2 distribution ratio. However, you might want that like your servers are like of a nature that their performance keeps on varying, so you may not want to keep a static ratio forever. So in that case, what you might think is you might want to have dynamic ratio. So in that case, what will happen if, let's say, initially your server A was responding better than server B, so the F5 set up a dynamic ratio of 3:2. Then after some time, what happened, server A got a lot of requests and its performance degraded, So then what F5 will do, F5 will automatically swap the ratio and maybe make 2:3, considering that server 2 is doing better now. So in dynamic ratio, it will be ratio based, but ratio would keep on fluctuating based on the server performance. Now the dynamic ratio method is used especially for load balancing traffic to real networks, real system, Windows, and with platforms equipped with Windows Management Instrumentation WMI, or any server equipped with an SNMP agent such as UC Davis SNMP agent or Windows 2000 server SNMP agent. So what that means is that you need to have some kind of software on the server which can capture their performance, and then F5 can gauge the performance by polling that software. Okay, so pool settings. Now as you saw, we gave a name of the pool like ABC underscore pool. So you can give any name because this name is just locally significant on F5. It does not have any other significance. Health monitors. So you can associate health monitor with an entire pool rather than with the individual pool members. So if you recall, we added the health monitor as HTTP. We can also add TCP, or we can also have some other health monitor, but whatever you are binding should be appropriate based on the application that you are running on it, the protocol. Now action on service down. So what action on service down means is that if this setting is enabled and the target pool member goes down, the big IP system tries to choose another pool member and rebind the client connection to a new server connection. So imagine, like, what happens. You are connected to, you are accessing an application and you were redirected to server 1. At that time, when your request was sent by F5 to server 1 was up and green. However, while processing the request, there was some server performance issues and server 1 went down. So in that scenario, what will happen? By default, your request will be dropped because this server was unable to process it, and your connection, you'll have to reconnect to the application. I mean, you might have to do the browser refresh, or try to open up a new session. Now what I want, that in such a case, if this server which was holding your request, it goes down, then you should not have to reconnect or refresh your browser. You should just be simply able to connect to another server. Now in that scenario, what you'll have to do is you'll have to choose one of these options which we saw here. So you can choose none, reject, drop, or reselect. So I'll show you quickly these options. So this is the one, action on service down. So by default it's none. None means that F5 will silently drop it. However, these are the options. If you select reject, in the case of reject, F5 will send a TCP reset to the client, and the connection will be dropped and client will have to reconnect. In case of drop, it will silently drop it. In case of reselect, really it makes a difference, that if you have selected reselect, what it will do is it will transfer your connection from this server to the one of the other servers which are available. So in that case, you will not get any reset, or you don't have to refresh and reconnect. Your same session would be valid. So that's something we can configure at the pool level. Slow ramp time. This is again a very beautiful feature, which says what, like, what happens now. Imagine in a real-time scenario, we have these 4 servers which are being load balanced using the least connection method. Now one of these servers crashed, and you plan to do some patching, or some software upgrade, or maybe some hardware maintenance on this server. So for that case, this server will not be available to take the load, and in his absence, all the load would go to the remaining 3 servers. Now when you plan to take this server out, at that point of time, let's say the connections on the server were like the same as you see here, 459. However, what happens is that you want to have when you're doing the maintenance on it, then it's not going to get any connections, and the connection count on this server 1 will be 0. Now you have done the maintenance. Now you want to put the server back in the pool. So at that time, the other servers will have some connections, like let's imagine they have the same, though this will not be same, this would gradually increase, but let's say if this is the same 460, 461, 470, and my server A has 0 connections at that time, or server 1 has 0 connections. So what will happen, since it's a least connection method, so all the remaining connections which are coming will be bombarded to the server because it has 0 connections until it equalizes these other servers. So that sometimes in real time causes the server to crash, because a lot of connections coming to it at one go, which ideally would have been coming to distributed between 4 servers, or so what we can do in this case we can enable slow ramp time for server 1 and give it just some breathing space. So like if I say I want to give it slow ramp time of 20 minutes, what it will mean is that now server 1 will get more of the connections, but not all of the connections, until 20 minutes at least. So the new connections will be spaced out to server 1 in a gradual period of 20 minutes, not in maybe 1 minute or 2 minutes as they come. No, but what will happen, let's say this one has to receive, they are 460, 461, 470, so this one at least have to receive 460, but those 460 will be gradually sent to it, and in the meanwhile any extra connections coming will be simultaneously sent to the other members. So it's kind of modification to least connection when we are using slow ramp time actually. Then the other major thing is load balancing method, which we discussed. We have to choose one of the load balancing method. Then another concept is priority group activation. Again, this is something not very common, but yes, if it's in some scenarios it is required. So if you look at here, you have this setting called priority group activation, which by default is actually disabled. I have just configured in this case, so it's showing this value. So what this means actually, now think of a scenario that you have, let's say, 9 servers, okay, for the same application, but you do not want to use it simultaneously, and there are many people who don't want to have all the servers getting the traffic at the same time. So with priority group activation, you can specify the minimum number of members that must remain available in each priority group in order for traffic to remain confined to that group. So I'll just show you a diagram. Okay, so I have 9 servers from 10.12.10.1 to 9. The IP address is from 1 to 9. The sequence may be a little bit haphazard. So what I will do in this case, for each member I have given some priority. So for 7, 8 and 9, I have given priority 3. For 4, 5 and 6 I have assigned priority 2. For 1, 2 and 3 I have assigned priority 1. So this indicates that the server with the highest priority will get the traffic first. So in this scenario, all the 9 servers will not get the traffic at the same go, but these 3 with the highest priority will be getting the traffic initially. And I have mentioned a condition, minimum active member 2. So let's say these 3 are getting traffic, the other 6 are sitting idle at that time. The first server .7 goes down. It is not able to take any more traffic. It's down, marked by F5. So F5 will not send it any more traffic. In that case, minimum active member 2. Still my condition is met because the other 2 members 8 and 9 are still active in the highest priority group. So this group will be able to handle itself. However, if .8 also goes down after a few minutes, then what will happen is this condition of minimum active member 2 is met. What means, this is defeated actually. That means that now in this group only I have 1 member active. However, the condition says it should be minimum 2. So in that case, this 1 member will be taking traffic, plus the other 3 members of the lower priority group get activated, and F5 will start sending traffic to priority 2 members as well, which were sitting in standby till now. They have become automatically active without our manual intervention. Again, the same will happen. So these priority group 2 members will keep on getting the traffic until 2 of them fail. Then only 1 will be left, and then priority 1 will get the traffic and their turn will come. So we might do this, like in this case we have 9 servers, and maybe we have better hardware for 3 servers, so we give them higher priority. We want them to get the traffic first, and still we have 6 servers in the backup which may have not that good hardware, but still they are giving us an automatic backup, and without our intervention they will come into picture. So I hope this makes sense, right? You with me?
Yes.
Okay. So like how we configure, basically, see, I just now added these members. Okay, so if I have to add another member, what we do generally, just add a pool member to an existing pool. We just give it a name, let's say server 3, and then we give it an IP 10.10.10.1.13, and we just give the HTTP, and then we have an option for priority group. So here, if I want to put it in the highest priority, like the example that we saw, I will give it a priority 3, or I can give it priority 2, or I can give it priority 1, depending on my requirement. So I will give just priority 3. Let's say I want it to be the highest priority member. So what will happen, the others which already have the default priority of 0, now they will not get the traffic. This one will get the traffic first because its priority is higher. When this will be down, or this condition of less than 1 means like only 1 is there, so if this goes down, then it will start sending to the other servers. Then we saw already the connection limit we can set, and then the member, once the connection limit is exceeded, it will not get the traffic, and other members will get the traffic if they are available in the pool. Alright, the color indicators are the same: red, blue, green, black, depending on if it's enable, connection limit met, all the members are down, or if it's disabled, it's black. Blue means there is no member bind to it, or there is no monitoring associated, like maybe you not have associated HTTP or TCP monitoring. Alright, so that's about pools. In the next session we would be starting with profiles, which is little tricky thing, so we'll go into it in a lot of detail with some scenarios and case studies. So I think we should stop it here, and if you have any doubt in today's session, we can cover it up.
So for nothing, I'll just go through the recorded session, and if I have any doubts, I'll ask
Yeah,
you.
definitely, because now the things are getting little deep, and there is a lot of variety. So I would suggest that you go through this presentation and the book, and on a daily basis you can you can let me know if you have any questions. And there are some questions in this also, so you just try to answer this. This will also confirm you about your concepts, and then we can take it up from there.
Okay.
All right?
Can we install this F5 on Mac?
Sure. Yeah, you can
Because
install.
when I've done it, I got a problem.
No,
So I installed everything.
you are doing it on Parallels, or you are doing it where exactly? You are using VMware Fusion.
No, I have uninstalled the Parallels again, and now I tried it on Mac.
You try it on Mac means you have VMware Fusion, or how you are trying it on Mac basically?
I've installed the VMware, and then I've installed the F5-11.3, but I couldn't run it. I got some error when I was trying to do that.